Okay, this should finish up. This is your last example. So you could go ahead and try this one on your own, or you could just kind of wait for me to work through it. We'll have practice problems on these as well. So on the last one, you probably saw this little piece down here at the bottom that said use the ideal gas law to find density. It's kind of it's a kind of a typo. It shouldn't be. The box shouldn't be around that. But anyway, we're going to do that now. And so it's really just manipulating your variable again. So let's go ahead and take a look at that. And if we zoom in here, how are we going to find density? Well, we have to remember what density is, and that's just mass divided by volume. And so if we know that, then we can play around with this formula. So let's write down the original formula real quick. So that's going to be PV equals nRT. So we remember that we can replace the N with grams per mole. So if we think about density and we're like, okay, what is the density formula? So density is mass, or grams, divided by volume. Okay, that means we have to get the volume on the bottom and the grams on the top. Okay, so what we do is we rearrange this formula. So it's PV equals GRT over molar mass, like this. Let's go ahead and clean this up. Sorry, I said N was grams per mole. That was a misspoke on that. That should say grams divided by molar mass. There we go. That makes more sense. So here we go. So here's our formula. And what we do is we just get this part over that part, and we rearrange this whole thing. And that is what this formula here is. And so once again, the M is the same as grams. So you might want to remember it like this, that grams over, so volume, equal pressure times molar mass over R times T. But this whole thing here, this whole thing is density. So you might be able to replace that with a single number. So it's possible to replace that with a single number. So let's go ahead and take a look at a problem. It says, what temperature, okay, we're looking for temperature. What temperature must the propane gas, okay, we got a formula, at 1.03 ATMs be heated to have a density of 1.51? Okay, well, we got density. So let's replace both grams and volume, like I said, with density. So we're going to go ahead and do that. So that's going to be, here we go, 1.51, and that's grams per liter is our density. So there's our density. And that's going to equal pressure. Okay, ATMs is great. We'll use that, 1.03 ATMs. And then, okay, molar mass. Well, you're going to get molar mass from C3H8. So let's go ahead and add that up. So you got 3 carbons, so 3 times 12.01, okay, plus the hydrogens, 8 times 1.01, and you get 44.11. So 44.11 and we're going to divide that by trusty R value, which we know is 0.0821. And once again, I've been talking about this a lot, but that's because I have decided to use ATMs. All right. If you're using kilopascals, it's different. And so we have to remember that. So I have chosen to use ATMs to make that value easier for me. And then I'm going to finish up with temperature. And temperature is what we're looking for. So that's going to be our X. So we're just going to solve for X. and we will have it. So let's slide this down. So let's rewrite it. Solving for x. Remember, algebra, should have learned algebra by now. The x can just slide up where the 1.51 is. So it's just x equals 1.03 ATMs times the 44.11 grams per mole. All that divided by the 0.0821. And we're going to multiply that by the 1.51 grams per liter. There we go. Let's run it through. Okie doke. We got 1.03. Once again, make sure you're doing these, not just writing them down. Divided by 0.0821, and we're going to multiply that by 1.51, and we're going to get, I got 366.4832904. So let's go ahead and go with the 3 sig figs based upon that 1.51 value. So this value here kind of determines our sig figs. So let's go with 366 Kelvin.